Well, hello. Let's talk about Module 10 and the air currents that we discussed in class. You should have practiced with your globe like this. I also have a world map behind me. That's kind of fun, right? So let's talk about Module 10. I have some sticky notes to go over, but before we do, I kind of want to talk about a few things that your book hits on that we didn't have time to talk about in class, and actually maybe a little beyond the depth of this course, but your book does talk about it. And I feel like it really helps some of the other things that you do have to know kind of make sense if you understand this. So let me try to explain this really quickly. So this unequal heating of Earth, remember the Earth is turning like this. And if it wasn't turning so fast, then or if it wasn't tilted, either way, if it was straight on and the sun was always hitting right here, then as it turned, this part would always be hot and these parts would always be cold, but it is tilted. So as it goes around the sun, we see how a different part of the Earth is facing the sun at different times of year, okay? But we also have that spin creates that Coriolis effect. Remember, the Coriolis effect doesn't really have anything to do with the globe. It's a physics term, okay? And what it means is that if you try to throw something in a straight line and you're going in a circle, it's going to appear to curve or actually curve. So when we do that on the Earth, as the Earth is spinning, it causes those air currents to deflect to the west or the east or to the northeast or southwest. So looking at that, factoring all that in, it's really important to realize that actual, like that unevenness in the way Earth is heated, where I'm trying to get where you can see. So let's see, let's see Africa, okay? So Africa is tilted, okay? So at this time of year, Africa is close to the sun, but as we keep turning, now Africa is down here, so the air is hitting more on the northern hemisphere. So we've talked about this, we've talked about seasons, but that actual unevenness, that axis of the Earth and that unevenness of the heating is what causes this air to circulate around the globe. So if it wasn't this way, we would always be cold here and we would always be hot here, but it is that way. So we are actually, that air is able to move itself around the globe and keep the whole Earth at a livable, inhabitable temperature. Okay, so just a couple things before we look at the sticky notes. Your book talks about adiabatic heating and adiabatic cooling, and this is that part I was talking about, a little bit deeper than environmental science probably needs to go, but I feel like it really helps us understand how the air moves around the globe. So your book cites four ways, four properties of air that help determine how it circulates in the atmosphere. And these are on page 114 in the first paragraph under the blue letters. And it says that they are density, so the density of the air, the water vapor capacity, how much water it's able to hold, how much moisture, humidity, and then the adiabatic heating or cooling, and then latent heat release. Okay, so let's kind of look at those a little bit. What I want to focus on here, so the first one is density. And density is that, you know what density is, like how many air molecules are there in a certain volume, okay? So if let's say we have a random 100 liter container, and in that 100 liter we have one that has 50 air molecules and one that has 100 air molecules. The one with 100 air molecules is more dense. They're closer together. The air molecules are there. They're bumping into each other. They're hitting each other. They're crashing into each other because they're closer together. Okay, so that density of air definitely affects how it moves. So less dense air is going to rise because it doesn't have as much density, like weighing it down kind of. So it's going to rise. And then more dense air is going to be closer to the surface of the Earth, okay? Or closer to the, underneath the less dense air at least. So then the second one says that air circulation capacity to hold water affects it. Okay, so I want you to think about areas where it's like really, really hot, or even here in North Carolina in the summer when it's really hot, we also have what we call humidity, which is that like moisture in the air. Okay, so hot air, warm air has a higher capacity for water vapor. So it's able to hold in more water in general. It's able to hold in more water, and so we get more humidity. And then cold air is going to be, you know, the opposite. It's going to be more dry. So then those are the first two properties. The third property is here is where we get how it changes in relation to pressure. Okay, the first one was about density. Second one was about how much water it holds. This one is about pressure. Sorry, I don't want to forget anything, so I'm looking at my notes I wrote for you. So okay, when we talked about the Earth and we talked about these layers of the atmosphere, you have to picture them coming out from the Earth, okay? As we get out here, we have less pressure because the atmosphere isn't sitting on top of us, okay? The part of the atmosphere, of Earth's atmosphere that has the most pressure is the troposphere. It's where we live. So I want you to think about that as air too. As the air gets higher up, it's going to be less dense, right? But here's what happens. As that air goes down lower into the atmosphere, the pressure on it is going to be stronger, okay? So as the air rises, getting away from the land, getting further into the atmosphere, it is actually going to become under less pressure. And when air is under less pressure, let's picture those, 100 molecules being squeezed together really, really tight. And then all of a sudden, we open it up and they have more space to spread out. So the pressure is less. They're not being squeezed as much. So they can spread out. And as they spread out, they stop bumping into each other as much. And those collisions are what create energy. And we can think of heat as being generated by this energy. So as they're colliding less, they're actually cooling. Okay, so as that air rises into the atmosphere, it expands and cools. And that is called adiabatic cooling. The opposite happens as the heated air and pressure increase. So you've got all these air molecules spread out, and all of a sudden they get pressed down to the earth and they get squeezed together. They're going to start bouncing around each other more, and more heat is going to be generated. And this is called adiabatic heating, and that helps us understand that air responds to pressure. Okay, so all of these things are factoring in. And then the last one is the latent heat release, which is just that release of energy when it rains, basically, when the water in the atmosphere is released. Okay, so keeping all that in mind, let's take a look at our sticky notes and just a couple things to tell you guys today. Let's see. All right, sharing now. Okay, these are your sticky notes for Module 10. So we just said this, as the unequal heating of Earth causes air to circulate around the globe. This moves around the warm and cold air. Okay, we talked about these terms. I don't think you need to memorize them, but understanding everything I just said will be really helpful for you in kind of putting it all together. Here I put a little bit of a comparison between warm air versus cold air. Just like I said, warm air is less dense, has more capacity for water vapor, and so we get more humidity. Cold air is more dense, so it's more dry and less humid. Okay, then convection currents in the atmosphere are what circulate this wind and air around the globe. Okay, those convection currents of the hot air rising and the cool air dropping form these convection currents that we've studied at length. Here on this page, it talks about how in this specific example, we're kind of looking at one small cell of an atmospheric current, not even a cell, not like a Hadley cell, just like one little piece of it, okay? And we can see, kind of pick this apart and see what happens. We've got cold, dry air up here at the, at the highest level of the atmosphere. And so it's cold and dry, so it sinks down to the surface, okay? And then as it's sinking and spreading, that adiabatic heating warms it. Okay, so it's getting warmer and warmer and warmer. Well, here as it gets warm, it's picking up moisture because now, just like I said on this slide, Warm air has a higher capacity for water vapor. So it picks up moisture and then it rises. And as it rises, it cools and it condenses around clouds and precipitation occurs. Okay, so kind of looking at how this dry air sinks, humid air rises, kind of looking at this whole process is really helpful to understand how these convection currents work on a larger scale. So I want you to think about it. When you go to the beach, often you can feel a cool breeze coming off of the water, like into your face, onto the land, okay? So maybe that helps you remember that cool air is over the water, and this will actually tie in more to what we have on the last page in just a second. Here's a picture of a Hadley cell, and all the cells work this way, just the arrows may be different direction. You should know this from your globe, but go over this figure and be sure that you can actually kind of tell someone how this process works. That would be actually a great assignment, okay? Go and tell somebody how this works, explain it to someone else, answer any questions they have, and that'll make sure that you're really getting it. Okay, Coriolis effect, remember, is that as the Earth is rotating, the wind is going to be deflected, okay? Global wind patterns result from the most intense solar radiation arriving at the equator, resulting in density differences and the Coriolis effect. So just like we talked about, these wind patterns are from the spin of the Earth and the tilt of the Earth, which causes the uneven heating. Okay, here, I cannot get you to draw this diagram enough. In fact, on your quiz, this is exactly what you'll have to do. Okay, you need to know where the cells are. You need to know these latitude lines for sure. And then be able to identify the direction of wind and the name of the winds. So not just looking up here at the picture, so just draw it in here as a practice. But you should have done this on your globe with your finger in your assignment, so you should be pretty familiar with it. But keep in mind that the direction the arrow, the wind is coming from the direction that it says. So if you can't remember how to draw the arrows, just remember, if it's a northeast trade wind, start in the northeast and draw it going, the opposite direction, southwest, right? Here we've got southeast, it's going to go to the northwest, okay? North is opposite of south, east is opposite of west, okay? Westerlies are moving from the west towards the east, and this is going to be a little bit stronger, a little bit straighter of an arrow than these, okay? But still kind of angled, but that's why it's not, these are not southwesterlies, these are actual westerlies because they're really coming from the west. And then at the north and south pole, we have our easterlies, our polar easterlies, or as I told some of you in class, a lot of times it's just drawn as a circle up here. Okay, rain shadow effect is something that we may not have talked about yet when you watch this video, but we will. And it's really important. I'm going to let you write this note, but I'm going to go to the next page and show you this. So we should cover this in class, but again, thinking of that cool breeze that affects you as you're at the beach, right? As winds are coming off of the water, they're picking up lots of moisture, right? Because they're over the water, so there's lots of water for them to pick up. So these are hot, moist winds, prevailing winds, that are picking up lots and lots of moisture. And as they get to the land, if they hit a mountain here, then this moisture is going to go into the clouds and condense around clouds, right? So as it condenses around the clouds, those clouds are then going to drop it because they just fill up so fast that they drop the water right back down. Well, then what air is left is dry, right? So as it continues to move inward, as it's dry, then on the other side of the mountain, we get a dry climate. And this happens a lot. We can see this in California as a great example of this. The mountains on this side, on the windward side of the mountain, that's the side on the ocean side, we get lots of moisture, lots of rain. On the leeward side, we get lots of dryness. And we'll do an origami project with this, so you'll actually get to look at it. But what this is really important to note is that things like geology and geography affect the weather and climate, okay? This climate over here is affected by the way that the wind is allowed to move inland because of these mountains. So geography affects climate, and climate affects, the area. Weather affects the different regions that it is found in, and it's all sort of related. So looking at these practice questions, I have the answers for you. I didn't put them here, but let's look at them together. I'll let you answer each of them on your own for this time. Let's see how you do, and then I'll give you the right answers and see, let me know how you did. All right, guys, that's it for now. Great work. Keep up the good work.